Hello everyone and welcome to Module 2. This is ELT140 and this is Hudson Rivera. And before we move on into the PowerPoint presentation, I want to show you what the plan is for Module 2. Okay, so first step, like always, you are going to, actually the first thing that you need to do every time is to go here to announcements and look for what the lesson plan for that module is. All right, not to mention any other announcements, but for the most part, I keep the announcements really short, only one per module. Okay, okay. So then here on module 2, so this is module 2 right here. The first step then is to watch this video that you're watching right now. And then after that, the Module 2 PowerPoint presentation is available for you there for reference. Then I would like you guys to watch, like always as well, the video or two. This time, I believe, I have this flow chart right now, but I might include another video. Okay, so how many videos we have here, that will be the next thing that I want you to do. Then go ahead and complete these 4 assignments. They are 4, but they are short. Okay, so homework 2. All right, after that, you're gonna work on this flow chart, and this is what I'm looking for. Upload a screenshot of a flow chart illustrating the operation of a garage opener system. First, you're gonna have to look at this video for things to make sense. But then the question will be, is the button for that garage door, is the switch on or not? If it's on, what's going to happen? If it's not on, you're going to keep in a loop looking to see, you're going to go back to the start. Am I turning on the switch? No. Okay, am I turning on the switch? And it's going to constantly be looking for that, and you're going to do that in your flow chart. Okay, then if someone pressed the flow chart, then operation will be enable or operate, open the garage door, right? Okay, and then the next step will be, so I'm gonna let you guys think through that, but think about it. The garage door is already up. Now the question is, am I pressing the button? Is the button being pressed to close the garage door? And you keep in that loop. Nothing happens until you press the button. Okay? And then once that button is pressed, now you have to ask yourself another question. Is the infrared light that at the bottom, I don't know what the name of that sensor is, if that being interrupted, is something blocking that garage door? If is, then you got to go back to the top again, where it's gonna open the garage door again. Okay, let me know if you have any questions, and like always here at the discussion, you make sure that whatever questions here you have, let's see, discussion, okay, so make sure that you use, if you have any questions in regards to anything in the module, then you can make sure there's always going to be a discussion forum here, and then just make sure that you can ask the question, or you can ask me directly, or text me, or email me, whatever works. All right, then we go to a controls project. Program the PLC using ladder logic. Upload a screenshot of it. Specification: a switch must energize 4 outputs at the same time. So here you are going to be using the Zen software, and you are going to program it in a way that one switch will energize 4 outputs at the same time. Okay, so you turn on the switch, all 4 outputs turn on, you let go of that switch, push button, or you turn it off, and all lights turn off. Okay, then finally we have I want you guys to review this folder. It's about 3 documents, and it's some information about that this application, fresh PLC application example, which I'm gonna go over a little bit. All right, and all what we are asking here is that just submit a question or a comment. Okay, should be very easy, simple. All right, so let's go to the PowerPoint now. Okay, so this is Module 2, and we're talking about, well, how do you go about selecting a PLC? All right, so it's important. You can see some in this list here: manufacturer, flexibility, programming, software, training, documentation. Okay, and as I mentioned before, we have two types of PLCs: fixed PLCs and modular PLCs. Fixed PLCs, everything is in one packet. Okay, modular, you have the processor and the modules. You can remove them from the rail, the back rail. Okay, and then this is using a fixed PLCs. Then everything is in there, like I said, right? Okay. In a modular one, you have the chassis, you have a power supply, processor, and modules. This is an example of Allen Bradley PC5, where you have the different modules. And we're talking now, one of the most popular for Allen Bradley is a SLEC 500, and it comes with these different slots. Okay, I'm going to be referring a lot to Allen Bradley because Allen Bradley has about 80% of all the market in the United States, so it's very good to refer to Allen Bradley. Okay, but we're going to be using the Omron PLCs. All right, I/O ports. Some of this stuff, guys, I'm going to be running a kind of fast because it doesn't really apply for what we are doing at the moment, but it's there for you as a reference. So you see, in this case, for Allen Bradley, we have this is the SLEC 500, and you see there's two models here, 501, and then you go to 2, 3. They all start with a 5. That's the same SLEC 500, and it goes from 1 to 5. And look at the memory size. So depending on how much your programs, how big of a application you are working with, then you will choose your memory size. Also, it has to also do with that, what kind of connections. We're going to talk in a moment about the type of communications that you might have. What kind of modules you might have. Well, digital, which is on and off, inputs or outputs. Analog, which is when you're sending a signal to an output, let's say 4 to 20 milliamps, or don't be that technical yet, but if you want something that goes from 0 to 100%, it's not the same of you opening a valve, which is on or off, open or close, or you start opening a valve slowly, and you are able to control, well, I'm opening this 10%, 20%, 50%, 100% full open, and the same with analog input. Analog input, you can have a level in a tank. Is the level of the tank completely 0 at the bottom? Is the way all the way at the top, which is 100%? Is it halfway, 50%? And then we have specialty I/O modules, different modules that it will accept maybe a pneumatic input. That's an example. And then we have networking modules. Which I'm going to show you in a second. All right. So let's take a look. So here you have different examples of input ports. You see this is a module. They have up to 12. Take a look at how you have the first one is I0, and then it goes to I11. So altogether you have 12 inputs. We always refer, the first one will be the 0. Okay, and then you have different switches here and even a thermostat. In your output port, then these are O0, O1, O2. Okay, normally it's, you gotta be careful when you are programming things because you see that O and a 0, it can get a little confusing. One of the biggest problems is that, for beginners is that you confuse. You want to write a type a O, but then you type a 0, and then you have a problem there. It will give you an error. So here are the different types of outputs. These are lights, green, red, and white, and then you have motors and a bell. Okay. Okay. Difference between sourcing and syncing. The difference is like it says here. Sourcing occurs when where the current flows out of the PLC port. See, this is your input, and it's coming from the PLC. You are sending current coming out through the device, going to your DC power supply, and going back to the common, what we'll call it, yeah, the common here. Okay, and then syncing is the opposite. You have the common, and then you're sending the power through to the device that is switching, and then receiving it through the port, the input port. I'm going to show you just really quickly this video, and I will be looking. Normally I show videos that shows me some kind of pictures that I'm interested. Sometimes there is a thick accent, but it's okay. Just focus on what I want here. At least see it this way. At least I'm showing you a video that is in English. How's that? So yeah, many times I try to find a video with what I'm looking for, and I don't always find something made in the United States. So sometimes we'll have a thick accent, but it's okay. So let's see. Oh, for some reason it's not showing it here right now. I get back to that. Okay, we have the channel 0 and channel 1. Those are the type of communications. Again, we're talking to Ellen Bradley. I'm going to skip this part with the channel 0, channel 1, but you can see it as this is channel 0 is used to attach peripherals, and the other one is to attach to a PLC or a computer, PLCs and PCs. Okay, so let's look at the different protocols that are used to communicate. As you see, you have the computer, and is connecting to a PLC. Is using the H+ in this case. Then you're going from the switch using Ethernet IP to this drive. So the whole point here, and this from this PLC, and you're going to these other devices. Then you have remote I/O network. All what I want you to see is there is communication protocols that are used, and they depend on what is the PLC connecting to. Are you connecting to a computer? Are you connecting to another PLC? Are you connecting to HMI? HMI is just a device that allows us to monitor and to communicate directly to the PLC. You don't want to have, you see, if you have a production plant, you're not going to have computers all over the place. You have the HMI, where people are only allowed to change whatever is that they need to change, like on/off. Do you want it to be in automatic or manual? Do you want to set up these to a specific temperature or flow or pressure? That is the kind of things that get programmed here in the HMI. Okay, which is HMI stands for Human Machine Interface. All right, gonna skip all that. Here is we're talking about field buses. It's amazing how many field buses are out there. All these are different field buses protocols, ways the PLCs communicate with other PLCs. And the reason why there are so many of them is because many are proprietary. They are used by different manufacturers. These are the configurations for a serial communication, where we have baud rate, parity, and data bits, stop bits, and the type of physical medium. We will talk, I believe, in this one, what is a scan? A scan is the time, is what is repeated a PLC scan is like running through everything that the PLC needs to do in order to update the outputs. Okay, so you see, you read inputs, execute the program, diagnostic communication, update outputs. So very much see it this way. You have inputs, you have the program, and then you have outputs. Okay, so a PLC scan is the processing time. Okay, when the PLC is asking to a new, kind of refreshing the input. What's my new inputs? To see if it has changed. Figure out through the program what's going to happen next, and then output, and then just send whatever output needs to happen. Okay, in response to whatever the inputs are. All right. Okay, and this is an example of a HMI. Okay, said. We are not there yet. Yes, we are. So these are some of the different modes and the PLC can be operating. Like let's say run. System can run, but its program cannot be altered. So when a PLC is running in a plant, in an application, is already in run mode, right? But while you are programming it, you don't want these things to be running, right? So then you will be in a, like in this case, offline program. PLC program can be modified while the system is not running, okay? Or you can set up, you know what, at this point, I want all the outputs to be disabled because I'm troubleshooting something. So disable turns all the PLC's outputs off or sets them to an operated state. So I hope that you can see how there's different modes for different needs, okay? While you're programming, you don't want your PLC to be in a run mode. All right. Okay, all right, let me see if I can go back to that original video. Let's see. Oh, enable content. Okay, here it is. Yes.
Welcome to another learning session on the PLCs. In today's session, we will see what are the different types of the PLC output cards available and commonly used. We first.
Okay, now it's better. So,
welcome to another learning session on the PLCs. In today's session, we will see what are the different types of the PLC output cards available and commonly used.
Okay, so what I want to show you is the different outputs available. Okay, and also I'd like to talk a little bit about the relays output. So let's see, PLC outputs.
Makes it easier to connect with the external devices. A relay is a non-polarized and typically it can switch either AC or DC currents.
Okay, so hopefully by now you are starting to see why the importance of relays, still and before and still today. Okay, a PLC will be controlling the output going into here to the coil. Okay, while here you can have a high power loop system, and simply when your PLC turn on the coil, then you will be able to allow the power to go into whatever you have here. Okay, and probably makes sense. This could be 120 volts. The neutral can go right into whatever it is. It could be a motor, and then the hot, it could be run through the contact going to whatever we are operating. Okay, and this will be. But now, these outputs actually have a internal relay. Okay, so these contacts that you see here will be actually these contacts right here. Okay, so you can see this is internal in the PLC. Okay, you actually can hear this clicking. When it click, when the output is enabled, you will hear it click. All right, let's go to the next type of
a relay outputs. Is an electrical operated switch. When the PLC output signal turns on, current starts flowing through the coil of the relay and creates a magnetic field, which attracts a lever and changes the switch contacts. If you need to switch AC or DC voltage such as 24-volt DC or 110 AC or higher, you need to select a PLC output card with the relays. Relay takes some time.
So the relays will be set up in your PLC, in your modules. You might get one for 120 volts or for 24 volts DC. Okay, so this will be part of the specifications for this output.
Close its contacts. So this means that the relay output cards are not suitable for high-speed switching applications. Relay output cards are suitable to turn on small solenoid valves and the contactors, but with the larger load state device.
All right, let's go to the transistor output. Guys, remember, this is in the PowerPoint. I don't want to make my time too long here, but this is in your PowerPoint presentation. Now we have the transistor output
that handles small to medium amount of current. Most transistor outputs in our PLC can handle only small voltage up to 24 volt DC. When output signal of the PLCs gives signal on the base of the transistor, it allows the current to flow from the collector to meter through the load.
So these are a solid state output. Okay, there is no moving parts, internal moving parts, and it works out of the transistor.
Transistor outputs can operate at high speed into several kilohertz depending upon the PLC model. Transistor output card can be used to send high-speed pulse signals to stepper and servo drives. It can also be used to generate PWM signal for some applications. Unlike relay output cards, there are no moving contacts in it, which makes transistor output more reliable if wired properly and installed.
So you see, it's used for high-speed applications when you want high-speed outputs. And let's see if we can move on to the next one.
In order to drive the load with the higher currents, we have to install some relays with these transistors. Trike output can be used to control AC loads only. When the output signal of the PLC gives signal on the gate of the trike.
Big difference here is that the trike are only for AC. Okay, so I'm gonna move on from that. All right, but take your time and go over the PowerPoint. Right. Let's see. Let me go all the way to the end. Okay, oops, all the way to the end. And let's watch this.
Robots think very logically. They make decisions and act on them. Every robot has a program, a plan for what the robot should look for, and how it reacts to what it sees. A flowchart can help us see that plan. Flowcharts are a type of diagram that represents a decision-making process. Let's follow the chart, starting at the start block. Blocks are connected by arrows, which tell you how to progress through the chart. Follow the arrow out of the start block. Action blocks contain a behavior the robot should carry out. The robot does what it says, then follows the arrow to the next block. This block is different. It's asking...
Let's go back here. So you see the beginning was a start, so you want to have a start. When you have a rectangle here, or a square, there's an action step there. Something is going to happen. Press the button or do something, right? It could be input, it could be output. And then this diamond one is the decision one where you get to select what's going to happen if the answer is no, or what's going to happen if the answer is yes. Did we turn on the button? Is the sensor, is the robotic system sensing that there is the presence of an object, like a plant? Yes or no, okay? And that's very much it. Just a lot of decisions, actions, and decisions to be made, all right?
Question, and has two arrows coming out of it. This is a decision block. The robot picks the arrow that matches the answer. Is the plant healthy? This one is. So we follow the yes arrow.
Let me stop here. So you see here we have the plant yes. More plants here. Is it, do we have more plants? Or are we done? If we know if it's done, then you go say, okay, we're done. Now, once that you finish with this plant, then you bring back to the beginning to wait for another plant. And it keep doing this forever until the machine gets to be stopped. And then at that point, you could even have a question here. Did someone press the button to be off? And then at that point, if it's off, then you're done. Okay. All right. So that was a bit of that was a bit about flowchart, and we are doing in 25 minutes. So PLC, fresh PLC applications examples, and here what we are doing is just going through the process of how does it look, how is control system spec, right? How does it work? How does it look like? So in this case, we have an example, PLC-based automation ribbon system, and I just want you to go over the different, what are they considering here in order to have a system that will be able to work with these bananas, right? So we're talking about humidity, and there is operation and audio-visual alarms. So go through this and just any questions or comments, and you're just gonna be posting them in as the fourth assignment in this module. Okay, so these are the specs for this system. All right, let me go back to here. Bananas. I don't like that it actually wants you to register, I believe, but let's see. Yeah. So the surprising, so read a little bit about, so what we want to do is understand the problem and then have an idea of what is the solution for this problem. Okay? Yeah, I gotta get out of here. All right. Okay, and then finally, let's take a look at this. Watch this video as well. That it will help you understand the problem and the solution. Okay? And that's it, guys. That is our work for today for this module 2. Okay? Yeah, so I think everything is straightforward at this point. And take some time and review the PowerPoint presentation here. Okay? All right, guys. Have a great day.